juxtaglomerular secretions and their regulation. Juxtaglomerular secretions are two. We have renin and we have erythropoietin. Now we will start with renin. So what is the source of renin? Source is Laces cells of the juxtaglomerular apparatus of nephrons. So renin is secreted in the nephron. Chemistry. Let's go to the chemistry. It is an acid protease. When you hear the word ASE, A-S-E, it means it is an enzyme. But we have learned that renin is actually a hormone. But if you go in the medical dictionary of Tabors, you will find out that renin is actually called an enzyme. So right now, let's call it as enzyme also and a hormone also for study purposes. So it is an acid protease and it is also a glycoprotein. What are the hormones, pre-hormones? There are two. One is pre-prorenin and the other one is prorenin. Now let us go to the regulation. In the regulation, you have increased secretions, factors which increase secretion and factors which decrease secretion. Now let us see the factors which increase the secretion. So we have here decreased blood volume, decreased pressure, decreased sodium concentration, increased potassium concentration, increased sympathetic activity, catecholamine release and prostaglandins release. So these are the factors which increase the secretion of renin. Now let us see the factors which decrease the secretion of renin. So we have increased sodium concentration, increased blood pressure, ADH secretion and angiotensin. So these are the factors which decrease the secretion of renin. Role of sodium in renin regulation. So let us see how sodium maintains the renin levels in the body. So we will start with decreased sodium concentration. When there is decreased sodium concentration, there is decreased filtration of sodium in the renal corpuscles. Why? Because if sodium is only less in the blood, the body will try to conserve it. So when body will try to conserve it, less will be secreted and more will be reabsorbed. So decreased filtration of sodium in renal corpuscles. Since it is filtered less, the concentration becomes less in the tubular fluid. So decreased sodium concentration in the tubular fluid. So this decreased sodium concentration is sensed by the sensors in the macula densa cells. The macula densa cells are susceptible to low sodium levels. Because of this, the RAS is activated. That leads to the formation of angiotensin II, which has a function of increased sodium reabsorption and increased water reabsorption, which restores the ECF volume to normal, and the sodium which has decreased will now come back to normal levels.